Bismillah ar-Rahman ar-Rahim. This is Mr. Hamada Hawas. I'm going to solve these physics model questions of the first year secondary first term 2019 and 2020. All the following questions are multiple choices questions, and I'm going to solve them with simple steps and explanation as you can see as following. Right, let's start. Question 1. Using the following mathematical relations that represent two physical quantities, quantity A equal half mv square, as you can see, it is kinetic energy, right? And by the way, it is energy. Quantity B, it is force by displacement, which is work. And as we know, work and energy are measured in the same measuring unit, which is joule, which equals kilogram meter square second power minus 2. And if we can find, or we want to find, is a dimensional formula, it will be m L square t power minus 2. So both are going to have the same measuring unit, have the same dimensional formula, so it represents both A and B. Question 2. A horse tries to pull a wagon loaded with wood. If the pull force of the horse represents an action, okay, which force of the following represents a reaction? This is Newton's third law, which states that for every action there is a reaction equal in magnitude and opposite in direction. Here is the reaction is the pull force of the horse on the wagon. So the wagon will react with the same force but in opposite direction, so it will be the reaction. So the answer will be the pull force of the wagon to the horse. Question 3. A stone and a pole are projected upwards at the same time, where the stone is projected at 20 meters per second. Okay, this is Vs. While the ball at 10 meters per second, this is Vb. The velocity of the ball, the maximum height reached by the ball is h, so this will be d, b the distance or the height of the ball. What is the maximum height reached by the stone, which is ds. Alright, here is the relation between distance and v. This is the third equation of motion with uniform acceleration in a straight line, right? This equation is, as we know, vf square minus vi square equal 2gd. In this problem, or in this question, or in this equation, as we know, reaching the maximum height means that vf equals 0. So it will be removed from this equation, and of course in both cases as a stone or the ball, g is constant. So the relation will be between vi square and distance, and we can summarize that if we compare between two bodies, it will be v1 square over v2 square, it will be d1 over d2. And in our problem here we can use the first one as vs square over vb square. It will be the distance or the height covered by the stone over the distance or the height covered by the ball. In the problem it requires ds or the height of the stone, so ds will be vs square, distance of the ball, divided by the v ball square. It is 20 square multiplied by h over 10 square, right? So it equals eventually 4h. So our answer will be D. Question number 4. The figure represents a ball falling freely from a height h above the ground. It takes 2 seconds here. Distance 1, which equals half h, it covered this distance or this height in 2 seconds to reach midway of the ground. What is the required time for the ball to cover the other half, right, of this one? Okay, given the g equal 10 meters per second. Okay, in this problem we should find the total height or the total displacement. How? Total displacement which is h, equals 2d1. And how can we find it 2d1? It will be 2 times half gt square. Don't forget that when a body is left to fall freely, as it's mentioned in the problem here, means that vi equals 0. So we just use this equation, half gt power 2, and we don't mention vit as the equation should have. So right now h equals half 2 gt square. It is 10 times 2 square, so it is 40 meter. Right now we will find the time taken by the body to cover this distance or this height, which is 40 meter, from the second equation also. Of course, d equal half gt square, where t square equal 2d over g, so we need t, which equals 2d over g, but under the root. Here it will be root 2 times 40 divided by 10, which equals root 8, which equals 2.83 seconds. This is the total time where the body covered half the distance in just 2 seconds. So what is remained right now? It is just 0.83 seconds, so our answer will be C. Good. Question 5. A projectile is projected from a cannon by 45 degrees with the horizontal to reach maximum height h and cover a horizontal range x. If the projectile is projected by another time by the same cannon at the same initial velocity, right? So vi in both cases are the same at an angle 60. So right now we have only one independent factor, which is the angle. In the first case it's 45, second case it is 60 degrees. All right, what will it change? Our maximum, which is the maximum range, only achieved if theta, or the angle of projection, is 45 degrees. If this angle increases or decreases, the maximum range or the range will be lower than what is mentioned in the first case was 45. So r will be less than x. So will more than x or more than x will be cancelled. We will have the answer B or D. But what will happen to the maximum height? Maximum height increases if we increase the angle of the projectile, and it decreases if we decreases it. But here in the second case we increase the angle, so it will be more than h, less than x. When two students measured the time taken by a copper sphere to fall freely from a building of 5 meters high, they got the two readings blue. The first student reading is 0.1 second and the second student's reading is 10 seconds. What do you think about the two readings? Before we just find if they are reasonable or not reasonable, let's find the time taken. We don't have to solve it, but let's try. Okay, t, as we mentioned before, it is root t 2d over g, so it is 2 times 5 over 10, which is 10 over 10, so it equals 1 second. This is the real time taken by the object to cover this height. And in this case, there is no students can in experiments find is that the time is 0.1 second. If you have the speed or the ultimate speed to press your stopwatch 2 times, the time will be more than 0.1 second. And second case, it is 10 seconds. It's a high time to cover this small distance, so the two readings are not reasonable at all. I don't know why I mentioned my name here. Alright, question 7. The graph represents a position of two athletes A and B who are moving in a straight race track in the same direction versus time. Okay, this is the athlete B, this is the athlete A. Okay, passing by athlete B. Okay, as we can see from the graph, both covered different displacement at the same time. They have t, which is equal 45 seconds, but what is the distance covered by A? dA equal, or displacement covered by A, it starts from 0, and in 45 seconds it reached to nearly 180 meter, whatever, nearly, or 190, whatever, it doesn't make a difference, okay? But distance of athlete P, it starts from where? Nearly 50, means that it started from a point which is behind the start point, okay, or the left side of the start point. So we will add 50 to 190, so it is nearly 240 meter. So it covered higher distance in same time, means that has a higher velocity. So athlete B will have higher displacement, will have higher velocity. So both displacement and velocity of S equal to, no, they are not equal. Displacement, yes, of athlete B are more than those of A. Okay, question 8. Figure 1 represents the change in position of a moving body X, which is observed in equal intervals of time, each of 2 seconds. Okay, so these are 0, 2, 4. Here it will be 10 seconds. So it covered 10 meter in 10 seconds. So its velocity will be 10 over 10, will equal 1 meter per second. But in figure 2, represent displacement time graph of another moving body Y, which statement describes the correct motion of the two bodies. Here we can find the slope. Okay, it will be 8 minus 4 divided by 2 minus 1. It is 4 meter per second. So Vx, and this is Vy, Vx over Vy will be 1 over 4, or Vy over Vx will equal 4. So whatever it is mentioned, they move at the same velocity now. Velocity of body X is twice, velocity of X is half, velocity of body X is quarter of body Y. Question 9. Using the following relations, F equal ma, Be, which is potential energy, equal ma times displacement. As we can see that Be in this case will equal F multiplied by D. And so the relation between the Newton, the measuring unit of force, and the Joule, the measuring unit of potential energy, is what? Here, this is measured in Joule. Force, it is in Newton, and D in meter. So Joule equal Newton times meter, or Newton equal Joule per meter. So what is mentioned? Newton equal Joule per meter, so it is A. Okay. If the length of a rectangle equal 5 plus or minus 0.1 meter and its width equal 4 plus or minus 0.2 meter, so the rectangle area equals what? Okay, this is a multiplication, and in multiplication problems we find the relative error of each one, then they are added together, then we find delta A, as I'm going to do. R, which is relative error, equal R1 plus R2. So R equal R1, it is absolute error, divided by the true length, plus 0.2 divided by 4. This is equals to 0.02. 0.2 divided 4 equals 0.05, so it is 0.07. This is R. Okay, and we know also that R equal delta A over A. Yes, the absolute error divided by the true value. So delta A that we need here equal R multiplied by A. R here is 0.07 multiplied by 5 times 4, which is the area. 0.07 times 20 equal 1.4 meter square. So this is delta A, so the area will be 20 plus or minus 1.4 meter square. The given figure illustrates two bodies, K and Z, of masses 2 kg and 5 kg respectively. If the body K affects the body Z on a collision with a force of magnitude F, what is the force by which the body what is the force by which the body Z affects the body K? Alright, these questions or problems depends on Newton's third law. For every action there is a reaction equal in magnitude, opposite in direction. So if K affects with F, Z will react with negative F in the same magnitude but opposite direction. So our answer will be A. So don't be deceived by these different numbers of masses, 5 kg or 2 kg. It doesn't depend on them. The same forces will be equal. But what will happen after the collision? The acceleration will change, or they return with different velocities. Question number 12 and the last one. The graph represents the relation between the velocities of two bodies. CB, it is a speed time or velocity time graph to find the acceleration. C and P versus time. What is the ratio between the acceleration of each of the body C to that of the body B, given that the slope is tan phi? Means that it gives you the relation that you are going to use. Of course, tan means the opposite divided by the adjacent, alright, so which is V over T. Alright, we want to find AC divided by AB. By the way, from these graphs and from the shapes that we see right now, the one with higher slope have higher acceleration, or with the one with the higher angle will have higher slope, so it has higher acceleration. So by the way, the acceleration of the body B will be higher than the acceleration of the body C. So right now we will remove A and B from this choices, and C and D will remain with us. How to find it? AC by AB will equal tan phi C over tan phi B equals tan phi C is 40 degree, phi B it is not 20, it's 20 plus 40, so it is tan 60, and this, when you try it with a calculator, you will find that it is 0.48, so our answer is C. Thank you.